Hey, so ratio of areas. Area APQ over area ABC. You see, they asked me for ratio, right? I choose to put it in fraction because I love to work in fractions. I don't like to work with the colons. Subsequently, I will go through more questions with you and you will see why it is more convenient to work with fractions. It allows you to do multiplication, allows you to equate different areas. Whereas if you work in ratio, you can't really do that. So when they ask me to find the ratio, right, I always work with fraction. Only the last step that I change it to ratio. Okay? So now area of APQ over area ABC must be actually the square of the ratio of length. APQ. I've got a 4 over there. And ABC. I've got a 6 plus 4, which is 10. So this gives me 16 over 100, which is 4 over 25. So my final step, I will show ratio of area. Area APQ to area ABC equals to 4:25. So this is my final answer. Do you have that? Then area APQ. They tell us that the area of ABC is 37.5. This big one, 37.5. And I want APQ. So, part B. This is supposed to be 37.5, right? Then what is this over here? (37.5) divided by 25 times 4. Okay, then you get the answer over here, which is 37.5 divided by 25 times 4. Six. You all get it? Okay, so that is the area. And finally, area of the quadrilateral PCQP. How much is that? 37.5 minus 6. So part C, area of blah 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 equals to 37.5 minus 6 to get us 31.5 square centimeters. Is the answer correct? Does it seem correct to you? You see, apparently the ratio of the area, right, is supposed to be 4:25. So if this is 4 units, by right, this should be 25 units. Does it make sense to you? Okay, it's supposed to lah, huh? It may not look that way, but it is. Looks like they didn't really draw it to scale also lah. Okay, doesn't matter. The maths works. Now, example 14. This is a question that doesn't involve any diagrams at all. But I need you to highlight this. Regular. Regular pentagon. What is a regular pentagon? How many sides? 5 sides, okay. When they tell us regular pentagon, what are they trying to say? What are they trying to tell you? What's the difference between a regular pentagon and a pentagon? All the interior angles are the same, all the sides are the same, right? So, all regular pentagons are similar because all the interior angles are the same. Similarly, all regular hexagons are similar. All regular, what else? Octagons are similar. Even though they may be bigger, smaller, but all the interior angles are all the same. So, they are all similar. So this is a case where they do not tell you they are similar. You are expected to know it. And now I'm telling you, so you better know it. So the areas are 49, 81. Find the ratio of the corresponding sides of the two pentagons. So let A and B be the ratio of the corresponding sides. So this is what I'll write actually, yeah. Since A and B are the ratio of the corresponding sides, right? So A over B square must be equals to 49 over 81. This is what I'll do. I will not use ratio like this. This is my answer. This is my working. Okay. Now I want to find ratio of area of sides, meaning I want A to B. So from here on, I know that A over B must be equals to 7 over 9. Did I forget something? What did I forget? Yeah, I take square root already, but what did I forget? Plus minus. Do I need to put plus minus here? Why not? Yeah, because it's understood it is a length. If there's no context, you will need to put a plus minus. So A over B is 7 over 9. Can you tell me the ratio of A to B now? 7 to 9. Okay? So your turn, try it. 14. I think 1 minute is enough. Okay, challenge yourself, see whether you can finish it in 1 minute. I'm sure you can do it. 5 to 8. I just need to square root both of them. 5 to 8. Okay? Now let us go on to the next part. Triangles with the same height. I want you to include this over here at the top of your textbook. They are not similar triangles. Okay, because for similar triangles, you already know how to find the ratio of area. Just square them, right? For similar triangles, square the ratio of sides. But this time, what happens if I have triangles with the same height but they are not similar triangles? Looking at this one, does triangle ABC look similar to XYZ to you? Obviously not, huh? The angles are all obviously different. But can I find the ratio of height ratio of area easily? Let's try to find out the area first. What is the area for triangle ABC? Half times. Okay, let me write it down. Area equals to half times BC times H. How about this one? Area half times YZ times H. If I want the ratio of area, okay, it'll be one area over the other area, right? So area ABC over area XYZ is actually equals to half BC times H divided by half XY times H. Correct so far? Now, okay, what can we cancel off? Half and half, H and H. Why is it that we can cancel off H and H? They have the same height. This applies for triangles with the same height. Huh? So then it is now simplified to become BC over XY. Highlight this. Okay, BC and X, sorry, not XY. Why did I write XY? YZ. When I make a mistake, please tell me. YZ. Okay. Now, what is the conclusion from here? What do you think we are trying to get you to learn? If the base, yes? With the base, we can find the area, provided that the height is the same. Okay? As long as the height of the two triangles are the same, and when you have the base, you can find the ratio of the area. Any questions? Then let me tell you a common mistake. Because students are very used to areas, ratio of area being the square of the ratio of side. Then when they come to this, right, they will think that area of this is what they will do, which is wrong. Let me emphasize it's wrong. Area ABC over area XYZ. Then they will write BC over YZ and they go and square it. This is wrong. Can you see why? Can you See why people make this kind of mistakes also? Yeah, because they confuse two different methods for finding ratio of areas. Okay, so please don't make this mistake. It is simply the ratio of the base. And it is proven with this working over here. Alright, so let us try an example. Example 15. Now we will give you diagrams like this, where it is your job to identify whether they have common height or not. So here we have two triangles, ABC, ACD. A, B, C, and ACD. Two triangles. Find the ratio of the area. Okay, area of ABCD. Okay, the entire what is this? Quadrilateral has an area of 21.5 square centimeters. I want the ratio of areas. Can you see that these two triangles have a common height? Where is the common height? CA. No, CA is not a common height. Common height, the height must be perpendicular to the base. Okay, it's shown over here lah. Let me do a quick recap with you. For any triangle, let me call it A, B, and C. Where is the base? BC is the base. Okay. Base, BC. Where is the height? What? Where is the height? A. Okay, a perpendicular line from A to BC. Right? Let me call this point X lah, so that we can write down what the height is. What is the height now? AX. Is BC the only base for this triangle? What other bases are there? Use another color. What other base do you want it to be? AB. Okay, if AB is the base, where is the height? If AB is the base, then the height must be, look carefully, so I have to extend this out. Must be perpendicular, right? Okay, let's call this Y. So what is the height? What is the height? CY. Okay, are these two the only bases? No, I'm sure I can find another base. What is the last base? Because triangle has three sides, so the last one must be AC. If AC is the base, where is the height? It must be from B, drop down a perpendicular line. If AB is perpendicular to AC, then you have the answer. But right now they are not perpendicular, so I draw a perpendicular line. This one over here. So this being Z. What is the height? B to a AC extended or AC produced. So that it will be BZ. Okay? Now I want to tell you something that is also important. This word extended and this word produced. Okay, listen carefully. A, B, C. I join them up. If I extend this line over here, let's call it D. This portion is known as AB extended. It is also known as AB produced. Understand this English term? Can? Because I will be using, we can use this for tests, for exams. And you need to know what it means. So the yellow highlighted part is AB produced. Or we can call it AB extended. Okay? Now, back to this. We see the triangles. I want to identify common height. From the diagram below, it says that, oh, this green color part is the perpendicular height for a triangle ABC. Quite clear, right? But do you also agree that this is also the perpendicular height for triangle ACD with CD as the base? Let me transfer this green line over to this side. Are they the same? Do they have the same length? Yeah, they do. You must be able to tell that. You must be able to show, no, you don't need to show. You must be able to realize that these two have the same height. And these two triangles, they have a common height. But the bases are different. If these two green color lines are the heights, where is the base? Which two are the bases? AB and CD, yes. So with that, I can easily find the ratio of area. Okay, I don't need to find the actual areas for two triangles. I just need to use the ratio of the bases. So area ABC to area ACD. Let's call this H. Let's call this H. So part A, my answer will be area